In this video, I just want to go over the purpose of the Rocker-Bogie suspension on the Rover and what the point of it is and why it's there. So first off, the Rover is quite a bit disassembled at the moment to do some upgrades on it, which are currently in the works, but still enough for me to show off how it works. So this big part here is the rocker, and this littler part here is the bogie, so Rocker-Bogie suspension. Now the point is that all 6 wheels will maintain contact with the ground at all times. So for example, I can lift up this front wheel and everything else touches the ground. Same thing with the middle wheel, same thing with the back wheel. And I can do so with any combination of lifting up different wheels, and all the other wheels will touch the ground, and all goes over a bump, all wheels on the ground. Inside of the Rover, there is a set of differential gears, meaning that if this rocker rotates this way, the other rocker will rotate in the opposite direction. And I will show that off in a moment. But the main reason for that is that if I lift this rocker up, you can see that the Rover, the body, also tilts as well. Essentially, the body of the Rover ends up moving to kind of be the average of the rotation in both of the rockers. And it just keeps it all stable. Here is the Rover propped up on a box, just so I can show the differential motion of the rockers as they rotate. So I can grab this back rocker and twist it, and you can see the front one moves in the opposite direction. So it's not possible for the rockers to move in the same direction because the gears in the middle will lock up. They just don't allow that. And that is what prevents the body of the Rover from tipping forward or backwards as it drives, because it's unable to spin freely on its own. It has to have both of them move in the same direction. Here is a close-up of the gears as the rockers move. You can see that as the gear on one side rotates, the gear on the other side rotates in the opposite direction, and that is that differential motion.